Okay, we come to the fourth safety feature of using electricity in the appliances. Okay, just to take note before I continue. Okay, this is the second part of the safety feature. Okay, so the first video that I have is under part A, okay, where I talk about the first three feature: fuse, earth wire, and your power socket. So if you have not read through this one, or you just miss it, okay, you can go back to click on the previous link, okay, to read the to watch the previous video, okay, under part A. Now, for this part here, we will talk about the next three safety features, your switches. Your switches, okay, the first one we look at your switches, your circuit breaker, then followed by circuit breaker, then followed by double insulations. Okay, same thing again, like the previous video I mentioned. Okay, when you look at when you look at the safety features, you need to understand how it works. After that, you need to tell the marker, or you need to write in a way that the marker knows that you understand. So the only way, or the way that I actually propose students do, is to actually use the keywords that is commonly used, whereby it actually highlight the meaning without any ambiguities. And after that, the last one is to actually knows where you use this safety feature, because some of the safety feature are location based. For example, your fuse, it has to be, for it to be effective, it has to be at the live cable. So likewise for the switches wise is the same as your views, where it has to be at placed at certain locations, which is useful, then you'll be rendered useful. Okay, as a safety feature. And one of the thing that you look at is your switches. Okay, let's say example, if you leave your switches at the neutral wire here. Okay, for example, leave at the neutral wire. What it does is when I open the switch, okay, to switch off the appliances. Now what happens is at this junction here, like you see in the picture here, okay, while the switch is off, but let's say a stranger happened to go and touch the casing, okay, or touch the appliances, there is a chance that because the appliances is still connected to the high voltage, to the live wire, to the power source, the current may actually flow down, okay, to the person, okay, through maybe the casing. It could be like various reason. It could be the live wire is touch the metal casing. So when a person touch the casing, the appliances is still connected to the live wire to connect to high voltage. So even though it's switched off, it's still connected to the high voltage. And when the person touch, he or she will still get electrocution. So in this way now, your switch will not function very well as a safety feature. So that's why for switches, it has to be done, or it has to be properly done, it has to be properly fitted at the live cable. Because only when it's at the live cable and when I switch off the switch, you will find that my appliances, okay, is open circuit, yes, but more importantly is that it will actually disconnect the appliances from high voltage. So in the event of, let's say there's a fault whereby my live cable actually touches the metal casing, maybe a earth fault whereby I have an earth wire to protect, but I may not have. Okay, so let's say in this event is when the person touches the metal casing. Okay, and if my earth wire is faulty or this thing, you'll find that the switch, which is switched off, what it does now is that the appliances is not connected to high voltage anymore. And even though when I touch the metal casing, I will not get any current flowing through me. I will not get electrocuted. Because why? Because the switch has actually successfully disconnect the appliances from high voltage. Okay, so here I want to highlight two things is that firstly, the switch location is important. Okay, for it to act as a safety feature. Okay, secondly, is like second thing that I need to highlight is the usage of the keywords. Is that when you write your answer, when you tell the marker what does switch you how does switch perform, okay, as a safety feature. When the use of right keywords will actually help to portray or illustrate your meaning without any ambiguities to the marker. So one of the keywords that you look at here is actually disconnect the high voltage from the appliances. This keyword is not new. This keyword you actually see in the fuse. Okay, when we talk about fuse, this is one of the keywords that we also use. So you'll find that this keyword keep repeating itself, disconnecting the appliances from high voltage. Okay, so just take note of the keywords when you write your answer for this particular safety feature. The other safety feature we have is a circuit breaker. Now, circuit breaker in the layman form, it is like a fuse. Okay, his main purpose is it will actually disconnect the circuit when the current is above a certain rating. So you will find that in circuit breaker, same as fuse, there are actually rating. Okay, 20 amp, 6 amp, 4 amp. It can even be like 25 amp or even 30 amp circuit breaker. Okay, the main purpose is when the current is higher than the rating, it will actually disconnect the high voltage from the appliances. Okay, in this case here, you see that the keywords is the same as the fuse, whereby you look at current, excessive high current. Okay, when you look at excessive current or you look at high current. Okay, remember here we look at the target of circuit breaker. The usage of circuit breaker is targeted at one thing: excessive current. So when excessive current appear, your safety feature circuit breaker will take place. Okay, it will actually so-called trip. It will actually disconnect the appliances. As a result, you actually disconnect high voltage from the appliances and you prevent any electrocution. Okay, circuit breaker loosely wise in Singapore, in let's say in Southeast Asia, there is actually three types of circuit breaker. Okay, three names are, but two types of circuit breaker. One we call the MCB, miniature circuit breaker, which actually behave like a fuse. Is meant for appliances, but in this case, the appliances, like it could be a series of light bulbs, bigger appliances. Okay, then after that, we have another type of circuit breaker. We call it the ELCB, the earth leakage circuit breaker. This behave like a earth cable, whereby I actually detect current in the earth wire, and what I do is I will actually trigger my ELCB to actually cut off the current by tripping it. Okay, so both of them actually function similarly to your earth wire and fuse. But just that earth wire and fuse usually is meant for one appliances, more small scale. Circuit breaker, ELCB, MCB usually is, I will reserve it for a series of appliances, like something like a bigger scale. So it could be like maybe 5 power socket or 5 appliances connected together. Each of them has their fuse and a wire as a first line of protection. Second line of protection you have is switches. The third line of protection you have is your circuit breaker. So your circuit breaker will actually be connected to various appliances. So the moment I have this third line of defense, the moment my circuit breaker trip, I will immediately cut off current to various locations of the house to prevent any electrocution or mishap from happening. Okay, so this is how circuit breaker works. Okay, it's like a fuse and earth wire combined together. Okay, keywords will be the same. It will be like I mentioned before, excessive current and disconnect high voltage from appliances. Okay, so take note of the keywords. Now, if you look at this is what I mean by circuit breaker at a bigger scale. This is a line diagram that you always see in industrial. When you look at as an engineer, this is what we call a line diagram, whereby you see the power supply is here. Okay, it's connected through various switches. Okay, you have a consumer unit, which is your fuse. Consumer unit is just like a power socket, a power bar, whereby you have different wires coming out to different locations. So what you have now is that at this location, or at one room, it could be your study room, you have many multiple, maybe lamps, or it could be sports light, all these things. Each of them, remember, each of the appliances have their own fuse and circuit breaker and their own switch. So that's their first line of defense. Second line of defense is their switches. Okay, so in event that these two line of defense fail, what I have is I have all the circuit breaker, all the switches all connect together, and they are connected to a circuit breaker, which is a third line of defense. Okay, your first line of defense, your first two line of defense will actually disconnect the individual appliances. The third line will actually disconnect the entire circuit for the room, maybe 3 or 4 appliances. So this is where circuit breaker come in. So you'll find that different rooms, they will have different circuit breaker here to control. And the even better one is that all these rooms or the entire house will also again connected to a bigger circuit breaker. So the fourth line of defense is another circuit breaker. So the moment my third line of defense fail, the fourth line of defense will kick in. So my main circuit breaker again will cut off the current, will trip. And now at the fourth line of defense, my circuit breaker trip, my entire house will be cut from power supply, will be disconnected from high voltage. And the entire circuit, the entire house, okay, I'll cause a blackout. But what I do is I actually cut off the current, prevent any high current from flowing in the circuit, preventing any mishap of electrocution. Okay, this is how the safety feature works in real life. Okay, you have multiple layers. Okay, so this in terms of calculations, we have one classic example, which let's say your house, you have various appliances, a fruit blender, refrigerator, oven, and kettle. Okay, so they are all connected in parallel. Okay, your power supply. Okay, they are connected to your 4 appliances. Usually they are connected in parallel. Okay, of course, the same reason you should know, okay, why items are connected in parallel. Okay, partly because of the ease of using. Okay, if 4 appliances are connected in parallel, I can switch off individually without affecting the rest. Okay, but same thing, I will also need to calculate their individual circuit breaker and even fuse rating. So the example that I illustrated here will be on the calculation of the circuit breaker, the fuse rating in the circuit breaker. Okay, so let's say, okay, the main MCB, the circuit breaker here is rated 20 amp. So is it enough to protect the house from enough to protect the 4 appliances? So how do you know whether the earth circuit breaker is enough? Okay, first thing you must know is earth circuit breaker protect all the 4 appliances. So the easiest to know is if my circuit breaker is 20 amp, rated as 20 amp, am I good enough to protect my appliances? The train of thought that you have to take note is I have circuit breaker is to protect 4 appliances and through a certain current rating. So which means that you need to know what are the current rating for each of the appliances. So the first line of thought that you have to take note is you need to identify the current in each of the appliances. So if I know the current in the first appliances, second appliances, third appliances, and fourth appliances, I will actually know the total current flowing in the entire house. And from there, I will be able to judge whether my appliances, the current that I draw from all the appliances, is it big enough to protect the appliances, to protect the house. My circuit breaker, whether is it good enough to protect the house. So if you look at the total current, okay, the total power of the 4 appliances, okay, so you have 2750 watts. Okay, that's for all the 4 appliances. So divide using a formula, power equal to IV, you will be able to find the total current draw by all the 4 appliances, which is 11.5. Okay, 11.5, is it good enough to, is 20 amp feels good enough as a circuit breaker for all the appliances? Okay, the answer is yes. Okay, so which means that 11.5, okay, at a rating of 20 amp, if the appliances are working normally, my circuit breaker will not trip. If I have excessive current, then my 20 amp circuit breaker will trip to cut off all the power supply to prevent any mishap from happening. The last one that we look at for is what we call double insulations. Okay, so just take note, the difference between double insulation and earth wires or even is the appliances itself. Okay, earth wire usually is meant for appliances with metal casing. Okay, so that live wire touches metal casing is a problem. But what happens when you have appliances that is plastic casing? How do you protect them? How do you protect the user? So one of the way that we use is double insulations. Okay, so double insulation it consists the idea of double insulation means there's 2 layers of protection. What are the protection that you looking for? What are the insulation? The first layer is whereby the cables, the electric cable, the live and neutral is actually insulated from the internal component. So which means my heating elements, whatever capacitor, whatever resistor, they are all individually wrapped with insulator such that they are not in direct contact with live cable. That's the first line of protection, insulation. The second layer of insulation is whereby the component itself is actually insulated from the external casing. Usually this second layer of insulation is the easiest because how do I prevent internal component from touching the external casing or to prevent internal current from flowing out to the external casing? The easiest one to use is I will actually use plastic casing. Okay, this is the easiest way for me to take note of or to take note. Okay, but of course this is not the only way. So let's say what happens if I want a metal casing, but yet I still want double insulation. So what I do is I will still repeat the first layer of insulation. Second layer, what happened now is because I have a metal casing outside. So what I do now is at the interior of the metal casing, I will actually have a rubber layer. Okay, so such that the rubber layer will actually prevent the metal casing from having direct contact with the internal components. That's how I achieve my second layer of insulations to get double insulations. Okay, so Symbol for double insulation is like a two square here. You actually see quite often in fans and hair dryer. This is one of the two common things you have. Where you can take a look at your home hair dryer or even your fan. Okay, you will see actually this symbol at the back or maybe at the side of the power rating. Okay, the double square is a symbol for double insulations. Okay, now the other one that you see double insulation more often is whereby you have appliances that uses two pin. Two pin, same thing is because I don't have earth cable. Earth cable, and sometimes I have no earth cable, but I have to use a metal casing. So what I do, I will use double insulations. The other classic example I mentioned before will be the plastic casing. Okay, plastic casing will allow me to use double insulation quite easily. Okay, so now this is where we come to the end. Okay, now so far I have run through part A and part B. You will find that there are 6 safety features that you need to take note. Okay, these are the safety features that generally is covered at O level. Whereby you have your year 3 and year 4, sec 3 and sec 4, or what we call your year 9, year 10. Okay, of your studies. Okay, these safety features, take note. Okay, you need to understand how it works. Okay, individually, each of the safety feature you must know how it works, and of course you must know the keywords that you need to write so that you will actually illustrate the meaning to the marker without any ambiguities. Okay, these the keywords, and using this keyword you can actually illustrate the meaning clearly. After that, the third one you need to know is the location. Some of the safety features are location based. Okay, live wire. Okay, you need to take place. Maybe the earth wire, it has to be connected to the earth wire has to be connected to the metal casing. These are location based. Double insulations, when do I use it? Okay, if I have two pin plug, what insulation should I use? Okay, what features should I use? So the first line of learning, the first line of checkpoint is you must actually understand the individual 66 features, what are the keywords, and what are the locations. From then on, okay, when you practice, you look at the questions that you are encountering. The next line of thought that you need to take note is that you must remember, in real life or in most of the questions that we give you, the 6 safety features don't occur together. You always have what we call the combo effect. Okay, the combo choices. For example, live wire, earth wire, I will actually use it in combo with safety with fuse. Double insulations, I will actually use together with it could be fuse. I could have multiple combo. Example, I could have a fuse in working in line with earth wire, and after that working together with a circuit breaker. So you need to know that how this combo feature, how this feature works in combo. Okay, whereby example, I could say that I have a fuse, I have an earth wire. So individually, you know how earth wire works, how fuse work. But how about how they work when they are placed together? For example, fuse, okay, and earth wire. It could be the simple case of earth fault, whereby my live wire touches the metal casing. Okay, so with the metal casing, what happens is the current will be flowing to the metal casing, and after that, it will flow down to the earth wire. So in this case, earth wire actually allows the current, it direct the currents to the ground, prevent electrocution. But here you have a problem is that the current will be constantly flowing to the metal casing. So you still have current flowing through there. So it's still not 100% safe. So this is where your fuse will kick in. Okay, your fuse, okay, when the live wire flow through the metal casing, there will be excessive current flowing through the circuit. Okay, so this is where your fuse will take place. Fuse, now you'll find that the excessive current will cause the fuse to melt and indirectly disconnect the appliances from high voltage. So now, because after the fuse melt, I will actually disconnect the current which is flowing through the metal casing completely. Okay, and as a result, I will not have any current flow in the metal casing at all now. So I have 100% prevent a disaster or electrical fault or electrical fire from happening. Okay, this is what we mean by when you have combo safety feature to actually have different layers of protections and which complement each other. Okay, so for starters, okay, for student starters, remember you need to take note of the safety feature. And after that, you need to run through the ideas of how these different features work hand in hand. Usually the combos you can refer back to your teachers or you can refer back to your worksheets. Usually it's quite common it's quite a common style of asking question. Quite a common style of questions. Okay, but in any case, okay, you can refer back to your teachers, or if you have questions, you can leave it in the comment bar. Okay, I'll get back to you ASAP. Okay, if not, okay, this is where I end off in the last section of practical electricity. Okay, see you.